Hey, hi everyone, welcome back to Codeators. And today we will solve a lead code problem which is valid palindrome. So, first we read out the problem and then see what are the feasible solutions we have. So, the question says as a phrase is a palindrome if, after converting all uppercase letters into lower letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers only. Given a string S, return true if it is a palindrome or false otherwise. So as per our question already says like what exactly we have to do. Okay. So basically saying it's a phrase, okay, and is a phrase is a palindrome if to convert all uppercase. So whatever we have numbers, okay, we'll first convert it into a lowercase, okay, and then like removing all non-alphanumeric characters. So alphanumeric characters are only all the alphabets plus your numbers. Okay, only these two consist or makes the alphanumeric values. So anything like question mark, exclamation, comma, spaces, these are non-alphanumeric. Okay, so it's saying that alphanumeric characters only. And what is a palindrome? So if you like, this is a palindrome, ABA. If you read it from this direction, it's still ABA, and if you read it from right to left, it's still ABA. So that's what palindrome means. So now let's discuss the example 2. Okay, race a car. So race a car. Okay, so if you remove these spaces, it will be RACEACAR. Okay, so if you read it in both the direction, these are not same. Okay, it's RACAE. Okay, and from here it's RACEA. Okay, that's why this is not a palindrome. First thing. The other one, this is a palindrome. Okay, I'm not gonna like write it or solve it. You can like observe this part. So what algorithm or what steps we're gonna follow is first, the easiest of all what we can think of is first step is for us to is make all characters into upper or lower. I'm going with the lower. Okay, second step will be for me is to identify alphanumerics or non-alphanumerics. Okay, alpha numerics. Numeric. Third step will be like comparison. We'll do the compare. Okay, string from both the sides, from left to right and then right to left. If both are same, then it's your true case, else it's a false case. Okay, so first what we'll do is, as we said, first we'll make it lower. So s is equals to s dot lower. Then we'll use list comprehension. Okay, so s is equals to dot join C4. So what I'm right now doing, basically I'm trying to remove all alpha, trying to select only all the alphanumeric values. Okay, so for C in S, okay, if C is alphanumeric, so this is a function. Okay, is alnum. Okay, so this basically provides you, if it will give you a true if C is a number or a alphabet. Okay, so what we are doing right now is basically we are going one by one and fetching from our string. Is it alphanumeric? If it is, then take it to our string. Okay, I'll print it. Okay, so this is the stage we have all the characters are in lowercase first. Second is basically we have removed all the non-alphanumeric values. Okay, and third is like the comparison part. So if s is equals to the reverse of s. So in Python, you can either write the reverse function or you can go with the, so this is the easy way I go with. Okay, so this basically reverse your string. Okay, it will create a copy in memory and it will reverse it. So if the original string or if original string and the reverse string are same, in that case, it is in a palindrome. So first I'll show you, okay, how the string looks like. Let's execute this. So this is how our output is looking right now. Okay, so if s is equals to s reversed, if this is the case, then return true, else return, in any case it will be false. Okay, okay, so it's passed all test cases. Let me remove this one. Let's submit this. Okay, so it passed all 488 test cases. So as per analysis, what you can observe is that it's taking time complexity. Okay, so the time complexity here is big O of n. Okay, and the space complexity is also big of n. Big O of n. So can we do any it more efficient way? So what we can do is we have another approach, that's the two pointer approach, and that what we will do will not require a space. What space basically? So here what we are doing, we are creating a copy here, right? When we are doing a reverse. Okay. So in memory, it's creating a copy, and also what we are doing is it's not that optimal. Okay. As in first step, we are iterating the same string. Again, we are doing a second round of iteration, and here also we are doing a third round of iteration. Okay, so it's not that efficient, but yeah, time and space is in big of n. If your interviewer asks for more optimal way, so what you can do is you can go with the two-point approach. How the two-point approach works is like, so in our two-point approach, what we'll do is, so this is our string, let's suppose this is our string ABA. Okay, so one string will be our, one pointer will be our left pointer, another will be our right pointer. Okay, so what we are going to do is we'll compare. Okay, if L is equals to R, okay, if that is the case, then move forward. So we'll shift the pointers. Okay, so L will be shifted to this and R will be shifted to this, and here B is equals to B. Okay, so again this condition will be true, B is equals to B. Okay, and that's how it's a palindrome. If we take a bigger example, so let's take we have something called A, B, B, and let's take a question mark and A. Okay, so what we'll do gonna do here is, again we'll put a left pointer and a right pointer. Okay, and if so one check we'll do is it should be your alphanumeric. Okay, alphanumeric. So first, if A is equals to A, yes, A is equals to A. Condition one is this is matching. Then the your pointer will move here. L will be shifted to here, as and R will shift to here, but it's in a question mark, which is a non-alphanumeric, so it will skip this one, okay, and it will switch to R. This will switch to here, okay, and again B is equals to B, so this is again a palindrome. Okay, so now we'll try to implement this one. So we'll have pointer left and right. We'll assign 0 to the left one, and right will be assigned to this one, length of string -1. Okay, we'll run a while loop, which is like left should be smaller than right. Okay, first what we'll do, we'll try to ignore all the non-alphanumeric one. Okay, so first like ignoring all the ignore the, what you can say, non alpha numeric one. Okay, alpha numeric. Okay, so for that we'll run another loop. It will be inside only. Okay, so it will be like left should be smaller than right. Okay, and uh so here basically we are in this part we are going to remove whatever is coming in from the left direction. Okay, so s dot left, so s dot left, if this is a non-alphanumeric, okay, so is num, this will what give, it will give, it is an alphanumeric, so for non case we'll just do a not operator. Okay, so what it will do is basically, if that is the case, we'll skip it, so the left will jump, left is equals to left plus 1, and so this is from all the left side. Okay, and the other pointer which is running from right end, right to left, in that case again we'll do left is more than right, and this time we're gonna with right, right, again is num. Okay, so if this is the case, then jump the right pointers, so r is equals to right -1. Okay, now which is our main case, if at this stage if left and right are not equal, it states that it is a non-palindrome, it's not a palindrome. Okay, so if s of left is not equals to s of right, then return false, else otherwise return true. Okay, so I'll just give you a quick walkthrough. First what we did is we pointed left and right pointers to each. Okay, then this step basically is doing what, if you remember from example, there was a question mark. Okay, so it is like a question mark exclamation a b p a. Okay, so if this was the case, so what it will do is basically the left pointer is here, and as soon as it recognizes, okay, this is a non-alphanumeric, it will skip to this point. Okay, again see it's an exclamation which is non alphanumeric, so it will skip. Okay, and this will be your actual value to compare, and now this will be your actual value to compare. Okay, so left is always pointing to the actual values which need to be compared. Okay, and what are the non values like non-alphanumeric, those will be skipped. So this is basically, this is for left hand side. Okay, similar case will happen if it's from the right hand side. Okay, so for this scenario, like a b b, and let's suppose you are having something like this, so your right pointer is here. Okay, and if you're switching, okay, uh so your next pointer right should next point to, from this it should point to this in its next iteration, so it have to exclude these values, right?
So to exclude these values, that's why we have written that while condition. So if it's saying it's a non-alphanumeric value, it will skip it. Okay, so that is for this one. I hope you have understood till now. And here is the part where we are doing the comparison. Let's submit this one. Okay, it's passed all test cases. Let's submit this. Okay, we are not incrementing the pointers. So this is the point. So what I missed is basically uh, moving off the pointers. Okay, these are the edge cases ones. Okay, which is responsible for moving the non-alphanumeric parts. Okay, now when we have the actual cases, so we have to move. Okay, left is equals to left plus 1, and right is equals to right minus 1. Okay, that's why this is this. Okay, so okay, I have to do it lower. So while comparing, as I said, we need to come. So what it is doing is it is comparing capital A to small a, which will not equal, as the ASCII values are not equal. Okay, so we'll do a lower. Okay, okay, fast all test cases, submit. Okay, I think it's pretty efficient from the previous one. So if you like this video, do give it a like, thumbs up. Okay, and if you have any suggestions or any doubts, post in the comment section and subscribe for more. Thank you.